Hello, pre-calculus students, and welcome to our continuing lesson on factoring higher order polynomials. In this video, we're going to do an example where we're given a higher order polynomial and we're given a factor. Okay, so this is kind of a nice case where we're given a factor already. So later on, we're going to deal with the case when we're not given a factor. So, and we want to find all the other factors. So we use synthetic division or polynomial division. So I'm going to make a note here. Divide f of x by a factor to find other factors. And since this is a binomial, the power is 1, the coefficient in front of it is 1, we can use synthetic division. So I'm going to put, we're always reversing this number, so this is x plus 4, so negative 4 goes in the box here. And again, the reason for this is we just want to be able to add instead of having to subtract at each step. That's the main difference here. There's really nothing else to it. The coefficients are 7, 24, negative 15, and 4. Okay, and I always do this, especially in these lessons, because one of the things that really is important is when we're doing synthetic division, we have to make sure all the powers are accounted for. So x to the third, x to the second, x to the first, x to the 0th. Okay, there's nothing that's being skipped here. If anything was being skipped, we would have to use a placeholder. So now I can do this, bring down the 7. 7 times negative 4 is negative 28. Add 24, negative 28 is negative 4. Multiply negative 4 times negative 4 is positive 16. Add, that gives me positive 1. Multiply negative 1 times negative 4. Negative 4, add, this gives me a remainder. And just so that I make sure this is correct, this is 7x squared minus 4x plus 1. This is x to the first, x to the 0th, and this is our remainder. Okay, and whenever you get a remainder of 0, you know that it's a factor, and it should be since it's telling us that. Okay, so now we know that f of x is equal to x plus 4 times 7x squared minus 4x plus 1. Okay, and we know that this is one factor, and if we want to find another factor, we need to just keep factoring this. Okay, so we need to find some way to factor this, and this right here does not look so simple to factor right here. Okay, so and there's multiple ways to do this, but whenever we get a quadratic, we can factor, right? We can complete the square. Or we can also use the quadratic formula. And all of these methods are perfectly fine. Just for the sake of illustrating this, I'm going to use the quadratic formula to factor this term here. So opposite of b plus or minus square root b squared. So in this case, that's 16 minus 4 times a times c, all of it over 2a. And this comes out to 4 plus or minus square root 6. This is 16 minus 28. Okay, so that actually is going to give me negative 12, which is this. So let me just write this out here. This is 16 minus 28 all over 28. And this right here is going to give me a non-real answer. So we can stop this problem here. So this is going to be our final answer for now, okay, because we end up with a non-real answer here. We cannot factor this statement in here any further without getting into non-real answers or imaginary numbers. Okay, so that's the end of it. But sometimes it is possible to factor this down a little bit further. In this case, it's not, so we're just going to have to leave it alone, and we'll have to end this problem here. We'll see another example later on in the lesson where we can actually continue factoring this and getting more and more results from there. Okay. So this video and the previous one is really a review, and it really captures what we've done up to this point, and hopefully you see that this is helpful to solving these higher order polynomials, but we still have somewhat of a limitation in that we're still given a factor here before we can do anything else.